OFDMA creates a more efficient payload delivery system. OFDMA uses 4G LTE's proven and foundational OFDMA technology for efficient access. It allows multiple users with varying bandwidth needs to be served simultaneously. 802.11a up to 802.11ac use OFDM, or orthogonal frequency division multiplexing, to deliver Wi-Fi data packets. Under OFDM, a device uses a fixed 20, 40, or 80 MHz of bandwidth to deliver the packets regardless of whether it's transmitting video or just sending a simple text message over a Wi-Fi network. We'll use a simple analogy using trucks to illustrate the difference between OFDM and OFDMA. For OFDM, each truck is hauling a payload or user data, one surfing the web, another uploading video from a soccer game, and a third sending a text message. This is like using 3 trucks of the same size to send the data regardless of how empty or full each truck is. In other words, OFDM inefficiently uses the bandwidth, leaving a lot of empty space. 802.11ax, however, uses OFDMA, or orthogonal frequency division multiple access, which allows resource units, abbreviated RUs, composed of a certain number of subcarriers or tones that divide the bandwidth according to the needs of the client and provides multiple individuals the same user experience at faster speeds. In our truck example, OFDMA allows a device to fill an entire truck with resource units, a payload delivery model that uses the bandwidth much more efficiently. Let's go into more detail on exactly how this is done using 11ax. We'll start by defining some terms and concepts. Multi-user, or MU, applies to multiple technologies in 11ax, so it's important to understand that the term multi-user does not reference a specific technology, such as multi-user MIMO. It means that transmissions between an AP and multiple Wi-Fi clients can occur simultaneously depending on the supported technology. 11ax defines the use of multi-user orthogonal frequency division multiple access, abbreviated MU-OFDMA, and multiple use, multiple input, multiple output MU MIMO technologies. OFDMA is a multi-user version of OFDM in that it allows multiple users to share the available bandwidth and transmit simultaneously. A single user gets the entire bandwidth at any given time regardless of the packet size. For a text message, this is like putting a small box in a big truck. Each AP can speak with only one device at a time. As such, they are client-centric with a randomized contention-based approach that regulates Wi-Fi to a free-to-send, first-come, first-served paradigm, which is untenable for modern high-density and large-scale deployments today. Multiple users are separated in the time domain only. In our example, we have user 1, 2, and 3. User 1 is transmitted first using the entire bandwidth, followed by user 2 and then user 3. In contrast, OFDMA is AP-centric. It enables 11ax AP to simultaneously communicate with multiple devices by dividing each Wi-Fi channel into smaller sub-channels known as resource units, or RUs, or sometimes called RU tones. The minimum size of one RU is 26 tones or subcarriers, which equals approximately 2 MHz. A 20 MHz channel can serve up to 9 users. The access point determines how to allocate the sub-channels, as each individual RU can be utilized for different clients that are serviced simultaneously. In other words, an AP can choose to allocate the whole channel, all subcarriers within a channel, such as a 20 MHz channel, to a single user in a given time frame, or it may partition the whole channel to serve multiple devices simultaneously. This technique improves the usable throughput for all devices connected to an AP. This reduces the use of the contention methodology that preceded 11ax and moves Wi-Fi from a contention-based to a schedule-based service, which is analogous to a truck with a smaller payload. This helps stabilize Wi-Fi performance, especially in higher density environments such as stadiums, convention centers, transportation hubs, and auditoriums. OFDMA is most useful when multiple connections transmit limited amounts of data, which allows the protocol to squeeze smaller data packets through multiple sub-channels or resource units. Think of a delivery truck that can only send a package to one house at a time prior to 11ax versus that same truck able to carry multiple packages to multiple houses, which is 11ax. Moreover, OFDMA is effective at all ranges, close, medium, and far, and can help mitigate overlapping basic service set or OBSS interference issues. Let's look at how OFDMA subdivides a 20 MHz channel into smaller frequency allocations based on multi-user traffic needs. The AP decides how to allocate the channel, always assigning all available resource units on the downlink or uplink. By subdividing the channel, parallel transmissions of small frames to multiple clients can happen simultaneously. The 20 MHz OFDMA channel consists of a total of 256 subcarriers. These subcarriers, or tones, are grouped into smaller subchannels known as resource units, with a minimum size of 26 carriers, which will accommodate up to 9 users for every 20 MHz bandwidth. For example, when subdividing a 20 MHz channel, 11AX AP designates 26, 52, 106, and 242 subcarrier resource units, which equates roughly to 2, 4, 8, and 20 MHz channels, respectively. 11AX AP dictates how many RUs are used within a 20 MHz channel, and different combinations can be used. Here we show a 40 MHz channel. There are 512 available tones or subcarriers in a 40 MHz channel. One tone equals a single subcarrier of 78.125 kHz. For high bandwidth applications such as video, the AP can decide to allocate the entire channel to a single user.